Welcome to my channel. In this video, we are going to see problems based on logic gates. Now, I'll go with some simple problems and slowly we will move on to problems which are frequently asked in entrance examinations like JEE Mains and other state level entrance examinations. Now, let's see the first one. The following truth table corresponds to the logic gate. So, here inputs A and B and output X are given. So, this is the truth table. Now, by looking at this truth table, we should be able to select a particular option here which is given. We have given the options given are NAND, OR and XOR. Now, when you look at the observation, you can see is A, B inputs are given and X is output, which is given in a horizontal direction, unlike in vertical direction. Now, as you can see, X is the output X is A plus B. When you look at your X, so 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So, it is basically an OR gate. So, the answer is OR gate. So, answer is B. Then, another simple example, a truth table is given which of the following gates is this type of truth table. Again, A and B are inputs, Y is the output. Now, when you take this, the options are given as the following: XOR, NOR and OR. Now, here you have the Y is A plus B bar. Look at this. 0 plus 0 actually is 0, but it is 1, Y. So, Y is 1 means it is A plus B bar. Then 1 plus 0 is 1. So, 1 bar is 0. 0 plus 1 is 1, bar is 0. So, 1 plus 1 is 1, but 1 bar is 0. So, it is this formula and therefore, the option is NOR gate. A plus B OR, we have seen OR, and A plus B bar gives you NOR. That means OR gate followed by NOT. So, NOR. Now, let us see the next one. Here you have a combination given with gate 1 and gate 2 and the conditions are given: A is equal to B is equal to C is equal to 0 and A is equal to B is equal to 1, C is equal to 0. Then the logic gates of the output D are. So, in these two conditions, we have to identify what is this D. So, first of all, we will see in this condition A 0, B 0, C 0. Now, this is gate 1 is OR gate. So, gate 1 is OR gate. So, output of this will be A plus B. Output of this will be A plus B. And okay, so if 0 and 0 are the inputs, output will be 0. Output will be 0. And C is also 0. Then this is a NAND gate. This one is NAND gate. That means this output of this will be, now let us say I will put this as some input, this one output P, I will put it as P. So, here P is 0 and C is 0. So, this is 0, this is 0. Now, for a NAND gate, then when both of them are zeros, then you will have P dot C bar. AND is A dot B, NAND is not. So, bar. So, P dot C bar. So 0 dot 0 bar, 0 dot 0 is 0, 0 bar is 1. So D is 1 in this first case. Now let us see what are the two options where we have first case 1. So first case 1, here you have 1, here you have 1. So these two can be eliminated. So in these two, now we have to select the answer, the next one. So now in this next option is A is equal to B is equal to 1, C is equal to 0. Now if I consider the next one, A is 1, B is 1. So your P will be A plus B. So A plus B will be 1. So A plus B will be 1. And then you have P dot C bar. So that is 1 dot 0 bar. 1 dot 0 is what? 0. So 0 bar is 1. So second one is also 1. So this is the option. So answer is D. Answer is option D. So this is how you can eliminate a few options and then easily work out with the next one. Then let us see here. Now to get an output 1 from the circuit, the input must be. So what are the possible inputs to get output 1? So here A, B and C, this is an OR gate and this is an AND gate. So OR gate, so the output will be A plus B, and this is C. So Y should be equal to 1, that is the condition. So Y should be equal to 1. Now C is one input. Now this is AND gate. For an AND gate, the output will be product of these two inputs, that means A dot B. So here A is A plus B, or let us say Y. So Y dot, so output is, okay, here Y dash, because here we have Y, so Y dash. So output will be Y dash dot C. Y dash dot C, because it is AND gate. Now for that, either A or B can be 0 or 1, whatever it is, but C must be 1. So let us look at, because if 1 plus A is 0, B is 0, then it will be 0, right? 0 it cannot be. So one of them will be there, but C must definitely be 1. We know that because it is an AND gate, C must be definitely 1. So where is the option that where we have C is equal to 1? So this is C is equal to 1 option. So answer is C. Answer is C. Then let's see here. Now we have two given options. So this is 1. So this is 1. This is 2. Now we need to identify with this combination of gates, NAND gates. These are all NAND gates shown below. So what is the equivalent? Now what is this? So now when these two are connected, this is as good as a NOT gate. So here it will be A bar. NOT gate means here output will be B bar, and then your C is the output of this NAND gate. So C is equal to A bar dot B bar bar. Now from De Morgan's law, you can write this as A bar plus B bar bar. Now that must be equal to A plus B. So now when the output is A plus B, it corresponds to OR gate. It corresponds to OR gate. Now in this one, A is the input, B is the input. So it is a NAND gate. Therefore AND is A dot B, because it is NAND, A dot B bar, and it is both are connected here. So it is as good as a NOT gate. So this will be A dot B bar bar, because it is a NOT gate. So that will be equal to A dot B. Now A dot B corresponds to AND gate. So now first of all, out of these 4 options which are given, first of all we need to see where do we have OR first. So OR we have in these 2 options. In these 2 options you have OR first OR. First one is OR. And then second one is AND. So where do we have AND? Here you have NOT. So obviously this is not. Here you have AND. So this is the option. This is the answer. So this is simple one. Very simple one. The combination of gates shown below produces. What does it produce? What kind of a gate? Here there are options given: AND, OR, NOR, NAND. Now let us see. Now this is gate 1. G1, G2, G3, G4. Now G1, G2 are NOT gates, G3 is NOR gate, again G4 is NOT gate. So I'll put this, so what will be the output of this? A bar. What will be the output of this? B bar. Now A bar and B bar are now inputs to the NOR gate. So NOR gate, what is the output? A bar plus B bar bar. It is NOR gate. That means OR gate followed by NOT. So A bar plus B bar is for OR, NOT is bar again. So A bar plus B bar bar, and that will be equal to A plus B. Now again you have NOT gate, so this will be A plus B bar. So again you can write this as A dot B bar, A dot B bar from De Morgan's law. So the option is NAND gate. A dot B is AND gate, A dot B bar is NAND gate. So the answer is NAND gate. So option D.